And we're on to page 3 here of the practice test for circles, which is Unit 8. And we're going to start with question number 15. It says in circle B, the measure of angle ABC is 30. So that is a central angle. Central angle is 30 degrees, which means the arc is also 30 degrees. The question wants us to find the measure of angle CDA, which is an inscribed angle. And an inscribed angle is half of the arc. So it is half of 30, which is 15 degrees. Question number 16 wants us to find the measure of angle C. Measure of angle C is on the outside, so it is going to be half of the difference of the two arcs. The problem is I do not yet know what arc BD's measurement is. So I'm going to have to find that one first. I can see that I have arc from B to A is 110, A to E is 120, E to D is 80. So this is whatever is left out of that circle. So I'm going to take 360, and I'll subtract 110, I'll subtract 120, and I'll subtract 80. And that'll tell me my arc. And after I do all that, that is 50. So this arc here is 50 degrees. So the measure of angle C is half of the difference of these two. So the primary arc is 120. I'll subtract the secondary arc, which is 50. Remember, I'm subtracting because that angle is outside of the outside of the circle. If it were inside, you add those two arcs together, but since it's outside, I subtract them. 120 minus 50 is 70, and half of 70 is 35 degrees. For number 17, now I can see where they cross on the inside. So I'm actually going to find, I'll call this angle 1. I want to first find angle 1. So the measure of angle 1 is equal to half of the sum of its two arcs. So the primary arc to angle 1 is 66, plus the secondary arc, which is 50. So the measure of angle 1, I do 66 plus 50, and divide by 2, I should get 58 degrees. Now, that's not what they're after. They're just saying this angle here is 58 degrees. So how do I find the measure of angle 5? Well, the measure of angle 5 plus 58 degrees makes up a straight line, so it has to add up to 180. So subtract 58 on both sides, and the measure of angle 5 is 180 minus 58, which is 122 degrees. And that brings us to question number 18. Now this might be the toughest one on the entire practice, in my opinion, because the question wants us to find this tiny little sliver that is the shaded region. All right, so as I think about this shaded region is part of the entire sector, but not part of the triangle. So what I'm going to do is I'm going to take the area of the sector, and I'm going to subtract the area of the triangle to equal the area of the shade. So I have to find the area of the sector, the area of the triangle, then I need to subtract them. All right, so the area of the sector is the angle divided by 360. What shows me the angle is 60. So 60 out of 360 times the area of the circle. And the area of the circle, if it has a radius of 5, is pi r squared. So that is 25 pi. That's the area of the entire circle. All right, and if I were to multiply this out, 60 times 25 divided by 360. And math, enter. 25 over 6. So this is 25 pi over 6. That's the area of the sector. All right. Now I have to find the area of the triangle. And the area of the triangle is 1/2 base times height. And I can see that that's a 60-degree triangle. And since it's 60 degrees and it has two different radii, so if that's 5 and that's 5, this actually makes this a 60-60-60 triangle. So it is equilateral. So let me put in a little equilateral triangle here. Maybe. There we go. There's an equilateral triangle. And I know that the distance is 5 and 5, and this base down here is, the whole thing is 5. So this area is 1/2 of the base, which is 5, times the height. So how do I get the height of this triangle? Well, you do have to use a little bit of extra geometry knowledge here. Since this altitude is in a equilateral triangle, it actually is a perpendicular bisector. So each of these two pieces at the bottom are 1/2 of 5, so they're 2.5 apiece. And it is a 90-degree angle, so I can do a squared plus b squared equals c squared. So if I start thinking about just one of these two triangles, so I've shaded one of them in, a squared is 2.5 squared plus b squared, which is h squared, has to equal the hypotenuse, or 5 squared. So h squared is 5 squared minus 2.5 squared, and then I square root it. So the square root of 5 squared minus 2.5 squared. So the square root of 5 squared minus 2.5 squared. This should give me the height, which is about 4.33. And this height is about 4.33. So in order to find the area, I have to do this height times 5 times 1/2. Let me go back to my calculator. There's my height times 5 times 1/2, which is 0.5. And that area is 10.825. 10.825 is the area of the triangle. So the area of the shaded region is 25 pi over 6 minus 10.825. So 20, let's put that in here, 25 pi over 6 minus that answer right there. So I get an answer of about 2.26. And it wants me to round it to a single decimal point, I believe, round to the nearest tenth. So this answer rounded is 2.3 units long. Actually, it's 2.3 square units. That is an area, so that is 2.3 square units. Again, probably the toughest problem in this entire review is question number 18. And what makes it tough is finding the area of that triangle, because you have to do so much to get that height. All right, question number 19, we'll finish up page 3, and it wants us to find x. So because the angle is on the outside, the measure of the angle, So 30 degrees, the measure of the angle, is half of the difference between the two arcs. The primary arc is 90 minus the secondary arc, which is 2x. And I have to solve this for x. Get rid of the 1/2 by multiplying both sides by 2. That makes 30 equals 60. The 1/2 is gone, and I'm left with 90 minus 2x. Subtract 90 on both sides. That gives me negative 30 is equal to negative 2x. And divide both sides by negative 2, and I get 15 for x. So x is 15. And that'll do it for page 3.